Hello YouTube, I Fix It All here, Team I Fix It All. So I've got myself a snatch block here I got at Tractor Supply. And the item number is 1078301. It's a 20,000 pound snatch block. Overall, when you stare at these and you see them in the Tractor Supply, they look pretty durable. And then you go to use it. I've used this a half a dozen times. Several times under some pretty strenuous conditions, but snatch blocks are supposed to last forever. At least if you go down to like an old antique store or, I don't know, garage sale or whatever, and get one that's been in the family for... These things are supposed to last forever, and this one didn't last but a half a dozen times, and I wanted to drill in to find out what the root cause was. What keeps this pulley in place is just a snap ring on each side. Just a snap ring. That's it. I've lost one because this thing just exploded right on the tree. Right on the tree. I have it a chain around a tree and a hook right here. And what I like about it is you can quickly open it up, lay your cable in, close it, hang it back on the hook. Which is an element of most all snatch blocks, not every one of them. A lot of times they're so trapped, you got to take this nut out of the pulley, slip your cable in, fight your pulley in, you know the drill. But all that was keeping this whole thing together down at the working end of this was a little snap ring on each side. And so I'm going to get in a little bit of detail and I'll explain to you what happened here, my root cause analysis. When you buy them from the store, if you just kind of hold them in your hand, you'll notice that there's a natural... scoot go over and you can probably see it. When you hold them in your hand at the store, I'm trying to get you to see there's a gap. That's all I need to do is move that a little bit. Yeah, there's a gap right there. Right up here. I'm trying to squeeze it so you can... Now that gap contributed toward the problem, and actually that gap is, let me square it up better. It's a pretty decent thick gap. Now if you put a hook in here under tension, that gap is going to sandwich shut like mine did. And when the gap sandwiches shut, there's not a lot of wiggle room down here for the snap rings. There's grooves machined out. But when this gets cinched shut, because it's under load pressure, your snap rings are under the pressure right in here. Your snap rings are taking the brunt of keeping all of this together down here. See, it just naturally wants to... Watch this. I'm going to square it up and then watch all the separation that happens. It's like trying to do that. You're looking for the groove where the snap ring would be. You see how close that groove is to this flat steel? Now, I'm going to prove this to you by showing you that the witness marks of the snap ring are present. Here's a snap ring, and it tells me right there The snap ring has created a witness mark, and because it was under tension, so it was in a bind. This side, it's not so prevalent, but it's still there. You can see a shiny witness mark of the snap ring. The snap ring, honestly, should not... I don't like how that's under so much pressure. I'm going to try to solve this problem. It's not a bad design. You have a pulley. It's not a bad design except for this. The snap ring lives in a groove its whole life right in here on each side, and it's snugly up against each piece of metal. On the outboard side, here, and here. So 20,000 pounds, okay, 10 tons worth of pull, you know, but I wasn't doing that much work. This pulley has a little bit of weeble wobble in it, a little bit of play, and then this is machined out in such a way where it has a little bit of play. You can see the snap ring groove. If you add all that up between the play in here plus the play in here, that's not even normal wear and tear. That's literally over machined to allow you to have a little bit of play. Well, that means the snap ring is going to be under pressure. And obviously it was, because there's witness marks to show the snap ring popped off. I studied this. Let's call this our axle for a minute, okay? It's I don't mind the design of this. They've got you a grease fitting here, that when you pump grease into this grease fitting, there's a weep hole right here that sends it directly into the part that should be rubbing right here. And the way this should have been designed is this should never be allowed to rotate. This should be designed in such a way to where it stays stationary all the time. Sure, then put a snap ring on. It's not going to spin. The only thing that should spin is your pulley. Your pulley should spin on this. Allowing the pulley and your axle to turn means you're going to design it to allow a possibility that the snap ring becomes under tension and gets popped off, like it actually did. So I'm going to solve that today with my fix, but I want to get back to this to prove out that it did actually show signs that the snap ring was under tension. I've done a little etch and sketch here. Here's a side-by-side comparison of what I'm trying to illustrate. Something to point with. All right, so if we study each side that receives a snap ring, I noticed this side of my axle, per se, which was still holding its snap ring. I'm missing my other snap ring. I noticed that the groove machined out to receive the snap ring, when you have a system that requires snap rings, your machine work must be machined out in such a way that you have nice, clean 90-degree angles. Right like so. And that's what this side has. Nice, clean 90-degree angles. And let's see if I can get that to show up or not. Background. I don't even know. Everybody has trouble with metal parts showing up right. Now, this end here is good and clean, but this side over here, let's flip it over. This one has a nice machined out on one side, but it's rounded off. Yeah, let me lower it some. It's nice and 90 degree here, but then it's rounded right there. Let's see if we can show you. So overall, it was like, nice try, but no cigar. This definitely is a lot of decent metal in a package that's not exactly cheap per se. You have an expectation that you're buying you're under the expectation you're buying a hell of a snatch block, and then you discover what its limitation is. The limitation is the snap rings. So I don't have a choice. I have to fix this in a way that's fabricated, because they screwed me in a couple of different ways. The internal diameter of my pulley is larger than the internal diameter of this. In other words, this is machined out with a step. It steps up in the middle. And that's because they needed to create a stop point to where it establishes a guaranteed width all the time, so that the pulley is living in a slot that even after weeble wobble, the pulley's not going to be binding up against this. I understand what they did. It just kind of screws me into, I need to resolve the issue and get my snatch block back up and running. So hang tight. I'm going to go to step one of what I'm going to do to fix. So here's what I've done. I've welded the axle to the backer plate. That can no longer rotate. I've added a pad right here that's about an 1/8 inch thick or so that takes up some of that slack of that movement that can put tension on the snap ring. And that allows it to assemble like so. It's always going to maintain that gap. And then there's no chance of putting, well, it greatly reduces the chance of putting pressure on that snap ring. Therefore, more effort's being put on the pulley. And now that I've made this pivot point stationary, now we just simply have a pulley that's going to rotate as it should on its own axle. So there you have it. You guys have a good day. See ya.